Carnegie Mellon University in Pittsburgh, Pennsylvania. We welcome you to today's webcast on what makes a good software architect, the 2019 edition. My name is Shane McGraw. I'll be your audience moderator for today's talk, and I'd like to thank you for attending. We want to make today as interactive as possible, so we implore you to ask questions throughout the presentation. There'll be two different talks within the hour, so fire as many questions you can at us. And now I'd like to introduce our panel moderator for today, Suzanne Miller. And Suze is a principal researcher within the Agile and Government team here at the Software Engineering Institute. And now I'm going to turn it over to Suze. Suze, all yours.
Thank you, Shane. Welcome, everyone, and thank you for joining us today. I want to introduce our first panel, which is Ben Johnson, who is actually not at the SEI. He's a local... I said Ben Johnson. Yeah. Sorry, folks. Ben Northrup.
Thank you.
Ben Northrup. Ben Northrup is a consultant, principal consultant at Highline Solutions, and has over 20 years of experience in the software industry. We like to have an external perspective, so it's not just all about the SEI. So thank you for joining us, Ben. I will never call you Ben Johnson again, I promise. And John Klein. Hey, I got your name right.
Thank you.
He's a senior member of the technical staff here at the SEI. He's been working with industry and government clients, architects, program managers, lots of different kinds of people trying to improve their capabilities individually and as organizations when it comes to software architecture. John, thank you for joining us today.
Thank you.
So this panel and both panels are about what makes a good software architect, and this is our second installment of this topic. The first one was in 2016, and we have some recurring panelists from that, but enough has changed in the world that we thought that a new version, a new installment would be useful to the community, so we're here to do that. The first topic that we're going to talk about with John and Ben, we do have another panel coming in later, is about sort of competencies, bodies of knowledge, and technology. We've had a lot of change in the way we use technology in the last 3-4 years. Open source has become the way in many industry environments that we build software. Off-the-shelf software has become much more sophisticated, both in terms of tooling support and in terms of end-user support. And so this kind of changes the game when we start talking about architecting an end-user solution, because we're not just talking about architecting a custom set of components anymore. So let's start by talking about how do you make decisions about technologies that you're going to adopt? You've got to make a decision. Am I going to do custom? Am I going to do open source? Am I going to do off the shelf? How do you make and communicate those kinds of decisions in today's world?
Right.
So, John, you want to start us off?
Yeah. Well, yeah, I guess the first thing is if we go back, a lot of people say, well, I thought the point of architecture was to insulate us from all this technology. And if you go back 10 years or so, that was still the best practice in architecture. Right. But things have changed, right? As you said, all of this open source, off-the-shelf software, it's the way to go now. It improves your time to market. It's the way to get your product out there faster, do less of the infrastructure yourself. And so, if we think about what is architecture, well, one definition is it's the early decisions that are hard and expensive to change.
Right.
And once you make these choices about technology for your infrastructure or parts of your application, they can be hard to change. They tend to get you locked in a little bit. And so this technology selection becomes architectural.
Right.
And it really hit home for me a couple of years ago. I was working in big data systems, no SQL technology, working with a colleague at the time, Ian Gorton. And we came to this realization that there was this coupling of concerns, things that we couldn't separate out in the architecture between the data organization in your NoSQL database,
right.
Whether it's a document store or a key value store. That impacts how you build your application on top of it. The way that data gets distributed in a distributed database affects things like consistency. Sure. And that now becomes something you have to deal with in your application. You can't hide that. And the way it gets deployed across the network determines the kind of failures that you might see. Right? And so now again, you need different failure modes in your application. And these were things that you can't get rid of.
Right.
No architecture, no amount of architecture can make it go away unless you do something like rebuild the whole SQL abstraction layer. This big, thick.
Oh, that sounds like fun.
Well, yeah, that is one of the anti-patterns in NoSQL is, we say we're going to adopt that technology because it's faster, higher performance, right? And then we start thinking, oh, but it doesn't have transactions. Oh, so let me try to add that in. Or I've got this inconsistency, so I'm going to deal with that. And so trying to rebuild that
Sure.
layer instead of just buying an off-the-shelf or using an off-the-shelf product like MySQL or Postgres, something like that. So,
And that's part of that decision is once I've made the decision into this one technology, that's really when I find out where its faults are.
Yeah.
And then I have a hard time, this is where the early decisions part comes in, I have a hard time going back and say, well, I really should have bought MySQL instead of NoSQL.
Yes.
And so these are things that we might not think about as being architects' decisions that affect an architect today. If I don't understand the different technology choices that are available for this domain that I'm in, then I'm probably going to end up making some errors in terms of early decisions that are going to be hard to change.
yeah, go ahead.
Yeah, sure. So I think you're right. Nowadays, there are so many more choices, right? There's so many different solutions. And I think for me, the important part is that architecture is really all about trade-offs, right? That any decision that we make, has some benefits and has some costs.
Right.
And we need to be kind of deliberate about understanding both sides of the equation. I think if, you're designing an architecture and you want to be able to kind of switch from MySQL to NoSQL, you need to know that up front.
Right.
And I don't think you get it for free from kind of good architecture. I think there's a sense that, if you did this right, we should be able to, plug and play any different technology. And I don't think that's the case. It's something you really need to deliberately kind of build in ahead of time. And I've seen when this doesn't happen in kind of a couple different ways. I've seen when, an architecture is kind of wedded to one particular technology and down the road you get burned because the technology is not supported anymore or it doesn't really suit your needs. But I've actually seen the opposite too, where architects are sometimes too vigilant to build in this kind of portability or flexibility without really looking at the benefits and knowing whether, hey, are we really going to need down the road to switch from MySQL to NoSQL? What's the probability of that? Is that going to happen? Because there's a cost to this. You might have more complexity because you build in this ability of kind of portability. So it's really up to the architect, I think, to kind of weigh those trade-offs.
And not as much in all industry settings, although some of this happens in industry, but in government settings, certainly we run into the case where legacy is going to last forever. Forever being 40 years sometimes, right? It's not at the pace that we're changing technologies. Portability almost becomes a capital P. In terms of architectural considerations and architecturally significant requirements, because I don't know when this vendor is going to go out of business that I have based my architecture on.
Right.
And I don't know if my customer, the end user of this, is going to want to continue to support this application. Some things happen, somebody buys it, and now I can't use it anymore for various reasons. And so there's a lot more to portability in architectural trade-offs than we might have even seen 10 years ago. So
and working with I work with both government and industry, and in industry it's all about time to market.
yes,
How can we get something out there quickly, get a minimum viable product, start building on top of that, and that's one set of principles and trade-offs that you would make. On the government side, it used to be that the focus was on longevity,
Right.
building these very long-lived systems. Although now on the government side, we also see much more wanting to get things out fast.
yes,
And this tension between the way you get it out fast and the way you keep it living for 40 or 50 years, this idea of technical debt that the second group will be
Right.
talking about today is, I think, one of the fundamental tensions that we see, particularly with government clients.
So this kind of opens up, if you will, the competency areas that good architects really need to have their hands around.
Yeah.
And so it's not just about sort of some of the traditional, where are we going to put these relationships and where are we going to put these interactions. It's also all this technology base.
Right.
How does an architect today keep up with that body of knowledge and its expansion? So Ben, I'll let you start that one off.
Sure. Yeah, that's a great question, and the answer is it's really hard. There's just a lot to know. I
kind of knew that.
I think so I've been in for 20 years in the industry, and I think just every year it just seems like there's just this kind of expansion in every direction of new technology and approaches and tools and frameworks. I'm sure by the end of this there will be a new JavaScript library that I don't know about, and so I think for an architect, I do think that the organization looks to the architect to kind of have their finger on the pulse of technology and different approaches, and kind of setting the vision and what the organization should use. And so there is kind of this expectation that's kind of part of the role. I think probably the best perspective is to just kind of keep balance between kind of the depth and the breadth of knowledge, right? So I think whereas a developer really needs kind of deep pockets of knowledge, right? They need to know the language or the framework that they're using, and they need to know the ins and outs. They need to know the language, top
the
to bottom,
libraries,
right?
and
Exactly,
which are good libraries,
all the
and
syntactic
that,
sugar and so forth. For an architect, that's really more of a liability because of the opportunity cost. I think the architect really needs that breadth of knowledge. They need to know at a high level, yes, the language and the tools that the developers are using, but what other tools are out there and how do they kind of contrast, and what are the advantages and disadvantages and risks and so forth, so that they can kind of set the right direction.
Right.
So I think for an architect, it's really kind of being focused more on the breadth than the depth.
And so we tend to call that a T-shaped
Right,
person.
exactly. Right.
Or
right.
I like the pie-shaped person, a couple of depth. I can't only have one area of depth. I've got to have a couple. So, the pie-shape makes it.
Put two T's next to each other, you get pie.
And you get pie, right?
Yeah. And you put a few
Too
of
bad
them,
we
you
didn't
get a
do this
colon.
on 314.
Yeah.
Sorry. So we have a question. This is we're gonna test your breadth and depth.
Okay.
So Chiku Mihai, I hope I have said that name right, asked us what your opinion is on as function as a service, FAAS, as an architectural viewpoint. So have you run into that? And
Definitely have seen it. Ben, have you been doing anything with that yet?
Function as a service, well, I guess maybe if you could unpack, I have an idea of what the question is, but maybe not exactly.
So function as a service is the new virtualization where
I was wondering if that's what it.
Yeah, you write a small amount of code and you put it behind a REST interface, and you go to your cloud service provider and say, when I get a request on this interface, run this very short-lived function. It's
So is this related to the sort of microservices idea?
It's
Serverless,
related
I think,
to serverless, microservices, and they all fit together. It's an emerging thing. From one of the things we haven't really talked about, one area that I would argue you need to be deep in, if you got to pick a few, is cloud. And one of the big things about cloud is cost becomes a trade-off. So Ben mentioned earlier trade-offs. As an architect, we tend to think of cost, schedule, quality, but the cost of operating your system in the cloud is another trade-off. And so function as a service has some really attractive cost advantages. Right now, one of the things I see going on is the cloud service providers, Amazon in particular, is doing things with constraints and limits on function as a service. Your function can only use a particular amount of memory today, although that number keeps growing. It can only execute for a certain amount of time, although that keeps growing. There's things about the first time your function is called, it takes longer because it has to get loaded. But then if you immediately call it again, it runs very fast because it's already loaded. So all of these things, people are going to some very great lengths to build frameworks to allow you to do things in a function as a service environment.
So this is
Oh yeah, and I will say, and not to be a broken record, but it's all about trade-offs again, right? So it's understanding whether that is something you need. I mean, in some cases, you have a piece of a piece of logic that needs to scale, or the usage is kind of spiked, right? You have certain times of the year, certain times of the day where you really need to scale that component, and other times it's kind of dormant. And in those cases, it makes a lot of sense. The flip side is that I've seen is that. There's a decent amount of complexity added, right? And that complexity makes it more difficult to maintain. It sometimes makes it difficult to debug things when there's issues, and you've got a lot of kind of fine-grained services in play. This one calls that one calls that one, and tracing things and figuring out what happened at runtime can be difficult. So again, it's kind of the trade-offs, making sure that that you need the upside or the benefits.
Right, and getting back to this idea of technology as an architectural decision. If you do function as a service, you really need to buy into that cloud service provider's entire stack.
Right.
Because your function disappears. So if you want to store anything, you need to use cloud service provider storage. If you want to log anything, you need to use their logging. If you, so all of the cloud service provider's technology becomes embedded in that function. Trade-off is it's not a lot of code that you're writing.
Right.
So if you throw it away and have to rebuild it, maybe not such a big thing, but it is, again, a trade-off. You want to make it intentionally, right? Consciously.
Intentional decisions.
Yes.
All right, so a couple of follow-on questions that sort of relate to this. When we look at DevOps, and we look at some of these things like microservices and FAS and other things you're talking in cloud, how does the software architect's role change when DevOps is in the game, as it were?
Virtualization and containers, which is one of the core DevOps-enabled technologies, that's really changed the way you package and deliver applications. If we go back a few years, one of the things you always had to worry about was dependencies. And can I put these two processes on the same server? If you're in the Windows world, DLL hell, where you'd have incompatible versions of libraries and sorting that out. And containers allow you to package up your application and all its dependencies and deliver that as an executable unit. And so that's really changed the way that we think about deploying and scaling our systems. And it's the enabling technology for microservices. Right?
Yeah, I think so. And I think for an architect, it really opens, it kind of broadens the palette of options you have as an architect. I think in some environments, I've been in environments where it's really difficult to get new servers, deployed. You have a new solution and you really love to break this out of the monolith and run it separately, but to do that means to talk to the infrastructure team and get dev and test and QA in production environments and make sure that that's all set. When you have kind of a DevOps mindset and you have containerization, it opens the options for architects to design to be more flexible in what kind of solutions and to break things out and not just build the monolith because that's most convenient in terms of deployment, but to do what works.
So we're getting into an area that sort of broaches into the systems engineering. And there was a question that said, so do we really, this is a missed topic in many software engineering undergraduate programs, is another place to learn about this, the systems engineering discipline, if you're not getting what you need to know out of the software architecture. What are some of the things that the systems engineering discipline contributes to the knowledge that a good software architect has?
System, so two parts to that question, right? I mean, the first part is at the undergraduate level, software architecture is I don't want to say neglected.
That's what our audience said.
Yeah, well, it's a challenge because software architecture really comes into play when you get to a larger scale.
Yeah.
And as an undergraduate, the size of the systems that you're building, a lot of the software engineering and software architecture discipline, it doesn't add value at that scale. And so it's difficult for students to appreciate. But system engineering, system engineering helps with the idea of system thinking. And
trade-offs.
Trade-offs, analysis of alternatives, structured ways. A lot of what we do in software architecture borrows some of the discipline about how to make trade-offs from system engineering. So that's there. And at the same time, system engineering is paying more attention to architecture.
Right.
So I think there's flow in both directions.
No, I definitely agree from the work I've done in the systems engineering world.
Yeah.
So there was a question also about what are the regular activities as an architect, and I think we're gonna push that until we talk about what some of the other resources are that are available for people to learn about this. So hang on.
And that was also in the 2016 webinar.
Yeah.
That was more
That's
of the
one
focus.
of your resources.
That was one of more. Yes, and we'll have a link to that at the end.
Okay. So back to kind of our technology topic. All these choices, how do we make good decisions as a software architect, and how do we communicate them effectively to the systems engineers, to the other stakeholders that need to understand why these decisions have been made and why they should actually abide by them?
Yeah. So we had done some work, I had mentioned earlier when I was working on big data systems. And so, how do you make that decision about which NoSQL database you're going to use? And we came up with a process, a long name, the Lightweight Evaluation and Prototyping for Big Data method, or we called it LEAP for Big D, for BD. And if you look at it, it's a four-step process, right? Look at what's your system context, what's the technology landscape, what are your architecturally significant requirements, what's the problem,
and that's really the
solve?
unique part of this as a problem solving or decision making is
Yeah.
actually really understanding what is architecturally significant requirements.
Yep, and that varies from system to system. Look at candidate technologies and do some screening, get it down from the long list of possibilities to the 3 or 4 most likely candidates, and then go and do some prototyping to collect data. Now, when I say that process, it doesn't sound like rocket science. But one of the key things about decision making is to make your process explicit.
Make it transparent.
Make it transparent.
Right.
Yeah. And I think Ben, you and I were talking about that earlier. Right?
Yeah, exactly. I think that's the crux. Really, is really to define that process and kind of deciding how to decide. And that doesn't mean that the process has to be really bloated and formal. I mean, it's got to fit the organization. I've been in organizations where they're bigger, regulated, and so you might need a little more formality for that process. Sure. It's smaller kind of startups. I still think you need a process. You need something. You need to decide on how you decide as an organization. Having a process that's clear and transparent and is grounded in, this kind of mapping of business value to the decisions you're making. You just want to avoid, I think, I've seen in a lot of organizations where decisions are made by the architect on high or by a manager kind of in the ivory tower, right? This is the main pitfall of an architect, and they just communicate out the decision and that's what it is without getting input from stakeholders. And I've also seen the flip side, which is, the developer late at night slips some technology in there, right? Slips in a framework and you don't find out about it until a month later when, when something goes wrong. So I think
and now we need to buy a license for that.
Right, exactly. Now you need to buy a license.
Trial is
right,
done.
Exactly. And so I think, regardless, I think there needs to be kind of a consensus on how you make decisions. And again, it doesn't have to be democratic. Maybe the architect does get the final say, but something that allows the architect to get input from all the different stakeholders.
And in the places that I've worked where we had those kind of transparent decision-making processes, it does actually help with compliance to the architecture, and also helps with people feeling comfortable saying, "Hey, John, you said this is how we decided this, but did you realize that when you were looking at the technologies that these guys were out there because they solve X, Y, and Z problems that you're really complaining about right now. And
Yep.
that communication from the developers to the architects and vice versa, I think, is one of the important things. If the software architect is perceived as being this on high oracle, then that you can't ever question, then you're not going to get the kind of teamwork that you need to be able to build systems that are going to meet the business needs that are present in the organization.
Yep.
Yeah, and I mean the other thing that's when we were doing this Leap for Big Data process was you need to make the decision. You need to balance correctness or getting the best decision with making a decision quickly.
Sure.
Because in a lot of these landscapes, the technology is changing so rapidly that if it takes you a year to make a decision, the candidates that you started with are no longer, you've got different
Some
versions.
of them are out of business.
Out of business or new versions at
Yeah.
least coming out on a regular basis. And so being able to make a decision quickly and being, one of the things that I think makes a good architect is being comfortable with making suboptimal decisions. Right?
We call them satisficing.
Satisficing,
Right?
yes.
Satisficing is it's good enough
Yes.
for the purpose, but it's not perfect. And we're okay with that because we have time constraints, we have limitations on resources, all the things that we have to deal with in real world.
right.
Yes.
Right?
Yeah.
Yeah, and so I think you haven't said it, but I know you've said it before. Software architecture is about applying good decision-making, trade-off, et cetera, principles in the real world.
Yes.
That a software architect that just builds beautiful diagrams of what could happen, that's not helping your business managers. It's not helping you deploy to a new environment. It's not helping get things out to the warfighter. It's got to be grounded in the real world.
Yes.
Yep.
So, okay.
Yeah.
Is the architect role a dying profession? So we have someone that says that, with the rise of microservices, more focused components, do we really need software architects?
That's a great question, right? And especially, I think the other kind of angle on this is Agile, right? I think a lot of people think, hey, we do Agile, we're delivering every sprint. Why do we need an architect? We don't do anything up front. What's the architect do? I still think there's a need for an architect. I think John mentioned before, I think you need to hit a certain level of complexity or scale probably before you need an architect. I mean, if you've got a small startup with 2 or 3 developers, you don't need a formal architect. Someone needs to do the role of architecture and thinking. But I do think you get to some threshold where you absolutely need someone focused on making sure that there is a vision, making sure that these trade-offs are met, making sure that developers are adhering to the kind of the patterns and there's consistency and so forth.
So I have an example in my mind of an organization that that said they didn't have a formal software architect role. However, they made the decision, the development team made the decision to develop and deploy on a particular cloud infrastructure, a particular platform that had a particular set of pre-done architectural components, pre-done tools, pre-done. And my argument was, well, you made an architectural decision by going that direction. Now, you actually, if you don't have somebody paying attention to that, you're at risk for that decision not serving you beyond the short term. But you did make architectural decisions, and do you really want that to be just whoever happens to be the last one out the door at night? Who's willing to do the extra work to kind of research this? Or do you want this to be something that is going to serve you and have someone who can talk to the business side, not just to the developer side about why we made this choice instead of that choice. That's, to me, in areas where software architects have really proved their value, has been in that interface between the technical, the developers, the infrastructure, the IT, IA people, and the business leaders who don't necessarily understand the complexity.
I think that's exactly what happens when you don't have a formal architect. What ends up happening is you get the best developers, the most talented developers, but those developers don't necessarily make the connections with the business, and so you get decisions that are probably suboptimal.
Right. And business, if you're talking to management, they care about cost and risk.
Yeah.
And at the same time, you need to be able to turn around and talk to developers that care about tools and workflow and job security and those kinds of things. And so the skills that an architect needs in communicating are still there.
Yeah. So what I just brought up was this idea that sometimes the architect isn't a formal role, and it might be somebody who's a coder most of the time. We have some questions that kind of go along that. Is that common these days to have more part-time architect roles and people who are doing coding? And what risk does that bring into the play if you've got more of the coding kind of focus as also performing the architecture role?
Yeah, I think the challenge is focus. If you're coding, it's hard to code part-time. It takes some time to get into the flow. And being an architect often is a little bit interrupt-driven. And so just the working styles are different. That said, architect also codes is a well-known organizational pattern. So, it goes both ways. I think you want to keep the architect off your critical path. So one thing I've seen architects working on is prototyping tools, test fixtures, things that aren't necessarily on the critical path. So, good.
So we've been answering a lot of questions, which has kept us from some of the things we were going to talk about, but I think this is really where we wanted to go. There are some other questions that are more specific that we will answer, usually via email is what we answer. So for those of you that didn't get your questions answered, I appreciate your patience. We can't get to all of them. So we're going to close this section of the panel. I think we had a really good talk about technology, communication, decision-making. And we're going to move over to talk now about another topic that we did introduce in the 2016, but has come a lot farther. But before we do that, I want to make sure that we talk about SATURN, because that's the resource that many people can use to get more information.
Yeah, so the question about where can I learn more about software architecture. So we've been running the SATURN conference. This will be number 15. It will be in Pittsburgh in about a month from now in May. And it brings together speakers from a number of domains, going from internet to healthcare to financial services to Internet of Things, lots of different domains, people presenting experience reports. So these are practitioners, people actually doing architecture, talking about what works and what doesn't work with technologies and methods and practices. It's not a trade show. A lot of the conferences that we go to are trade shows with people trying to sell you stuff. That's not the way we work things. Personally, as good as the speakers are, for me the best part of SATURN has always been the hallway conversations and the lunchtime discussions. I have, over the years, built up a great network of resources, people that I can go to with questions when I have them. Have you tried this technology? What worked, what didn't?
Right.
It's a fantastic resource. Urge everybody to come out and visit.
I hope they do, because it's a wonderful conference. I've always enjoyed it when I can get out there. So. All right, and so we now are going to switch over, and Shane's going to talk about some things.
Yeah, while we get our next two speakers mic'd up, I wanted to give a quick plug for a new show that the SEI is developing called Cyber Talks. And each episode is a 15 to 20 minute conversation between SEI researchers or CMU collaborators about cybersecurity or software engineering related topics of interest. And you can subscribe to Cyber Talk on the SEI's YouTube channel, iTunes podcast, SoundCloud, and Spotify as well. So I'm going to kick it back to Suze. We got EPEC here, and Felix will be joining us in a minute.
So the second part, we're going to be talking about a topic that comes up more recently than it did 10 years ago, which is technical debt. And Ipa Koskaya, who's a senior member of the technical staff here, developing architecture-focused techniques. So you're very much in the bleeding edge sometimes, of techniques for industry and government customers. And this is where some of the things come out of for technical debt. And then joining us in a moment will be Felix Bachmann, another senior member of our technical staff. There he is. And he works on the front lines with our government and industry teams in improving their product quality, productivity, and architecture is a big part of that. So welcome to both of you. Good to get a chance to talk to you again. So technical debt is a term that many of our audience would be familiar with if they've been hanging out with us for a while. But for those, we've got a lot of people on the line. So for those that haven't run into technical debt before, could you give us just a quick explanation of why are we talking about technical debt and architecture in the same sentence?
Well, Ben and John set up the stage really well for us. It's all about trade-offs, right? Architecture is about trade-offs, and technical debt really gave us a very good vocabulary to be able to talk about those trade-offs. If I were to define technical debt, the way I would define it is you take some short-term decisions in expense of what might happen in the future. And a lot of those decisions are happening in the architecture context. We have a lot of examples of it. So that's why we talk about it in relation to the software architecture, and actually also in relation to how we formalize those trade-offs. Those of the audience that are familiar with our technical debt genre and the work so far will be familiar with the technical debt landscape. The way we actually position it is, yes, there are aspects of it that you find maybe if you're not developing the code properly, you keep injecting mistakes and bugs and so on, but there's a relationship between them. It's all about the invisible aspects of the system, architecture, the implementation, and now more and more the DevOps and the infrastructure are actually all related. So it's very hard to decouple, and architectural decisions really drive that. And we found significantly more examples where the harder to pay down, the harder to manage decisions are architectural, and those are the ones that we end up calling technical debt, because 10 years down the line, you've accumulated that and you don't know what to do with those. So that's why we're talking about...
And you've been paying the interest but not the principal.
And you don't even know what you don't know. So that's also the aspect of it. The trade-offs are there. You made those trade-offs, but you may not be aware of how to manage them and how to go about doing the work that you need to do.
So when we look at this, we talk about ILITs, the software quality, security, performance. Well, that's not an ILIT, but it really is. Performability really wouldn't work as a word. And we can see that we would have a negative effect on those attributes if we make bad architectural decisions. So that's the project level. But then we've got enterprises that have a whole portfolio of projects. And that's another set of trade-offs we have to make, because where am I going to put my technical debt money, as it were? And how do I decide when what are the enterprise level kinds of issues that I need to pay attention to across all my projects versus things that are specific to an individual project? Have you guys started to address that question?
We see it a lot in our experience, and I think Felix has a lot of those also.
Right. So what we actually see is that if you look at multiple projects and the technical debt they occur, that many of those items are actually items where the project does not really have control over.
Right.
So those are items that typically show up in the backlog, and those are the ones that kind of like stay at the bottom of the backlog because really the project cannot address them.
Right.
Those are items that you may need another team, you may need another product, or you may need funding, you need scheduling things, all things that they really can't do.
They're outside the project scope.
Outside of the project, we really have to do something across the enterprise there. So many of the items that at least we observe are the ones that actually are going across. Because the reason why the technical debt actually occurred was because of the impact that it has on the enterprise level.
And typically the cost as well.
Cost and schedule.
Yeah.
Those are two big things.
Right.
So arguments that, we know that we should do it differently, but really we don't have the money for it. And I also hear arguments like, well, why should I pay for the other team to make their life easier when I have to solve my own problem? So many of the items that we see are those that really need to be resolved on the enterprise level. The project actually can't.
So this is an area we were talking with John and Ben about, what is the changing role of the architect? And this is one of the things I would argue is an emerging role, is to be that enterprise level advocate for dealing with individually project issues, but all the projects have to deal with them. We need to scale the
Right.
servers. We need to make sure that we have the infrastructure environment for deployment that everybody can use. And all of those things are expensive enough that they will get sort of left out of the equation, because we all know manual ways of doing something, right? It's going to take me a little longer, but investing in the automation or investing in the process change really is an enterprise issue. And so this is an area where
Right.
the architect has a big role.
There's the enterprise level, but there's also the ownership, right? I think there are multiple levels of ownership that we're talking about here. First of all, I mean, of course, architects should own the architecture. And even if there's not a career path of as an architect or a role, someone owns the architecture.
Right,
But
that's
then
true.
who owns technical debt and who owns the impact of it across the enterprise
Yeah.
in terms of its propagating effects? And I think that's what we're seeing in some of the projects that we work with and in some of the examples. All right, if the architect doesn't own it and they have the insight into the technology, the infrastructure, and some of the tool chain that goes, then it becomes a problem. So
Right.
that provides a shift in the role of the architect. Yes, there are opportunities because there are more tools out there. Some things are easier to do, but there are now new challenges. The decisions are not as nicely encapsulated in the project level.
True.
They might actually
Yeah,
have
yeah, yeah.
impact at the enterprise level as well.
Right. There's also, so an organization even may have something that they call the enterprise architect, with the responsible to actually look across
Right.
the whole organization and do something. So what we typically see, and that's not just government, there's also big industry organization where they have multiple profit centers there, is that the role of the enterprise architect is probably too high level to actually have an impact on where the technical debt occurred, which is in the projects or in the product development. So something has to happen. So either the architect that's responsible for the product or the project has to step up and step out,
Sure.
and take more responsibility, take on the ownership that occurred, and try to push it in the organization. Or the enterprise architect has to kind of like come down a little bit more, try to understand what the real problems are and
Yeah.
how to deal with it, and take on ownership for those. So there is a lot of going on, changing in the roles of,
Right.
or I should actually say the traditional roles.
Sure.
Yeah.
Changing in the traditions.
Right. Yeah. How they interact. And unfortunately, we see it very often. The technical debt just ending up and saying, "I'm sorry, I can't do anything, because I don't really have the authority to do something." Now, you may remember, so all the years that we worked together, we always were pushing towards. It doesn't really matter if you have formally the authority. You have, as an architect, you have the responsibility to do something. If you think here is an item, a technical debt item, that need to be fixed at some point in time, then do not count on that someone magically in the organization will take that on and make that disappear.
There are no unicorns here.
No unicorn.
They are. The only one who is there who can actually do something is yourself.
And it comes back to who really makes it known to the project and the enterprise, right? If nobody is owning it, whose responsibility
Right.
is to make it visible? Because a lot of the times what we also see is if you don't know what you're talking about, or if everybody is aware of it but nobody really talks about it, it's like the elephant in the room problem, or everybody is holding it from a different perspective, then you're not able to actually be able to solve about it. So I think that's where the architect's role is also changing, because the architect makes the trade-offs, because the architect knows about the LTs. And it's not just making the trade-offs, but which of these trade-offs need to be revisited? When do you need to make another decision because you know the technology will change? You know things are coming our way. I mean, some of our listeners might be dealing with a lot of the intensive data systems, the AI systems, the machine learning systems, right? Okay, we know that that's going to come our way. Then what do I need to be actually setting up for it? So it's really the visibility at both the project level and the enterprise level as well.
So this brings in some questions from our audience, and I'm going to kind of combine two different ones. There was a question about sort of disposable architectures as people understand that we're going to have more and more things impacting, other than some government settings, I'm not expecting my architecture to last for more than a couple of years. So there's an architectural role there, but then there's also this idea of enterprise architecture as being much more focused on what we would call plan-driven systems and other kinds of architectural patterns and traditions that have emerged out of the Agile space. So talk a little bit about sort of how does Agile and thinking about things from an Agile perspective impact both that sort of enterprise view and the role of technical debt in general with the project?
So I'll start with the disposable architecture question. That's an interesting one because some domains actually do have the disposable intentionally.
Yeah.
And I'm not an expert in that industry, but gaming industry is one that I know is one because the technology changes, because the way some of the processors and the way they interact with the user changes, they actually do not intend to keep everything that's throughout, and they intend to change some of those. So that's one way where the nature of the technical debt might be different in that domain. So, but then again, it's a trade-off, right?
Right.
The trade-off you make is, okay, I'm going to make this as quick as possible with the intention, with the knowledge that I'm going to be redoing the system in a couple of years because that's a whole new product. I might have new things. I might reuse aspects of it, but again, that's the trade-off I'm making. So that's, I think, again, about the trade-off role of the architects and knowing the technical decisions from that perspective. The planning brings a short-term and long-term perspective.
Right.
And again, there, okay, I made that trade-off. What do I need to revisit? And is that really technical debt, or is it something that I'm willing to live with? So that's one aspect that I think there's similarities there.
And the thing that we run into in some of these very long-running projects is that question of when do we revisit? What are the triggers? So some of the best architects that I've worked at are very good at saying, if this happens, we need to revisit this part of the architecture. And when this happens, because there are some things we know are coming, but not in time for our initial release. When this happens, it's time to revisit. And that is very helpful to an organization that's trying to plan enterprise product evolution, whether it's industry or government. And so that's one of the competencies, I think, in, going back to the technologies discussion that John and Ben and I were having, having in your mind what are not just the current technologies, but what are the emerging technologies? How are we going to deal with virtual reality stuff? That's something that, the gaming industry's all over that, but I'm sure there are other places. I saw, an ad for using virtual reality to teach people better driving behaviors. Who'd have thought of that 5 years ago? So that changes the architecture of your insurance training program, if you're thinking about it that way.
That's right. So, the one thing I want to actually add to it, that we need to be a little bit more careful with the wordings that we use. So even if we say disposable architecture, what we really mean is not throwing it away. A disposable architecture is a tool for learning. I am working in a space where I know that things will change.
Right.
But I do not really have a handle on what is it that will change. But I do know in 2 years my architecture will be different. So I'm preparing for this. I'm saying, okay, my architecture is not static, and that's also one of the properties architects have to be taken into account for the future. It is not a thing that is done once and then lives for, I don't know how many, 10, 20 years or so. It is done for a purpose right now. It may live a couple of years, and it is purposely put into place to be changed to something else. But when I change, I usually don't throw away everything and start from scratch again. I can't afford that. I take what I have and try to adjust it in such a way that it will solve my next purpose. Now, hopefully, I can reuse whatever I had before, a lot of it, to make it faster to go forward. But you never know.
So this brings up, I won't say it's new, but it may be new to some of our audience, but as one of the quality attributes of the architecture, evolveability
Yes,
is
absolutely.
really a key element, and all the competencies that go into being able to deal with evolveability is one of the things that good architects really need to have. Is they need, it's not just the trade-offs, but it's being able to look ahead at emerging technologies and see how they may be affecting the attributes of your system, is your system even going to be needed in 5 years, or is it going to be something completely different? And all those things are things that I think, 20 years ago when I started getting involved in this subject were not things we talked about. We didn't even talk, evolveability wasn't even on our list at that point. It was, this wonderful, beautiful, big architecture and all these different diagrams, and isn't that wonderful? And now everybody goes and complies with it, and we're going to have a great system. And, that hasn't worked for quite a while. Right. And it's not going to work in our current technology and needs environment either.
And some systems actually need to do it even at the extremes. It's not just evolvability, but it's continuously being able to evolve it. It's not a phase that you evolve or change the technology or replace. It's being able to do that as a rhythm as part of your system. Again, the tooling environments provide maybe an opportunity, and not all domains will obviously be amenable to those, but it's really that continuous monitoring of the architecture. And that's why, again, the technical debt skill set becomes an architect's skill set, because it says you need to manage these trade-offs. It's not just about, I made the trade-off, life is good. No, I need to manage that trade-off because it might come back in a different way in the short term or in the long term.
So we started on the topic of Agile a little bit, but I want to pursue that a little farther because we do have, not as much as 10 years ago, but we still do have some people that in the Agile arena that say, just leave, you don't need to deal with architecture. Architecture will evolve on its own, evolveability. And in terms of technical debt, that's the other place where, I see some Agilists are not as clear about how they expect technical debt to be addressed in systems that are using Agile methods. Can you talk about some of the best practices that you've seen, or anti-patterns, either one, in terms of Agile spaces and how they're dealing with technical debt?
So the one thing that we say, and we say this very strongly, is first of all systems have technical debt. All long-lived systems have technical debt, whether they've been developed with an Agile method, with a waterfall method, with a more ceremonial or not ceremonial method. So that's because that's the nature of the software systems that we have. In terms of as you're going through the development process, how you deal with technical debt if you're doing Agile versus if you're doing some other process, that's where I think some of these practices come into play. And again, I think in the Agile, and I'm very, very happy that I personally don't see this as often. It's not that, okay, we're doing Agile, we don't need architecture. We've finally have been beyond those days. But it's, again, similar. Because I'm doing Agile, I might take some shortcuts because I want to optimize it. Then how do I make that clear to the development team, to the customer, that that was actually a quick decision, quick solution? I may need to revisit that.
It's intentional technical
debt. It's intentional technical debt. It's not just you're going through it hastily. And that's why it's a skill set. Because otherwise, why would it be a skill set if you need to avoid that? So that's right.
So let me bind that back to we just discussed here with the disposal architecture, or evolvable architecture, actually. So one of the factors that will actually push me to evolve my architecture is because I made mistakes in the past. I put shortcuts in there, so I incurred technical debt in there. So that's one of the reasons why I want to change it. So the more I need to be, as an architect, very well aware of what was the technical debt that I actually occurred. Because this is the main factor, main driving for the next version of the architecture that I put out there to fix whatever need to be fixed in some way. So what we see very often, actually I would say probably the only way I see actually something happening is when it is made visible. So if there is something that you know that need to be changed in the future, don't keep that in the brain, find some way to make that visible for everyone in their language. So if that requires funding, so you need to make it visible for those people who provide the funding. That might be investors, or it might be your manager, to make clear why you have to invest that money to make it better.
And in Agile settings, I've seen that done as making technical debt items part of the backlog formally.
Absolutely.
That's the visibility vehicle in
But keep in mind, not just on the project level.
But also
Because if it requires funding or coordination with other team, you even have to push it up to the enterprise level and make it visible there.
So tracking technical debt, all of these things kind of come back to a question that was asked by one of our audience members is how do you monetize and quantify the effect of technical debt on your system, on your project, on your enterprise, and how do you track that so that people understand? And I know that's one of the things that you've been working on recently.
Yeah, actually good point. So I see architects getting very frustrated when they see they occur technical debt. They make it actually visible. They go to the managers and try to make the case.
Sure.
Yeah, and they get this nice, we understand. Yeah, that's good. Thank you. Yeah, so we'll talk about that later. Right now, we have to do something else. So very frustrated, going back and saying, I didn't achieve anything. And there is an issue with making technical debt visible, because at the first time when you try it, to make clear what the impact is on the future, what the accumulation is a very difficult task and sometimes impossible to do.
Sure.
So as an architect, it would be in that case your job to say, okay, I have to pull back, but I keep tracking it. So that means ownership, as we said. You take on the ownership, and over the month or years to come, you track what actually happened because of that technical debt. And the more data you can actually occur, the more data you can get, the easier you will have it the next time, maybe there to make the case, why you need the funding or why you need to have the other team doing something for you.
And it goes the other way as well. Maybe you tracked it and you really did not need to prioritize it. That's also feedback to the architect. Well, I elevated to that level, but what other information I needed so that I shouldn't have elevated it early enough, or maybe I elevated it too late, maybe I did not have the right amount of information. It's really about that feedback loop, and that's where I think the Agile methods become very powerful because they provide opportunity for that feedback loop quicker rather than later. Incorporate it into your sprint planning, incorporate it into your retrospectives and some of those review cycles, because there are many opportunities that actually help collect the data and put it into any of the tools you're using, because today, like Jira or any of the tracking tools have those opportunities to track them.
So we've talked, I'm glad we got into some of the things about sort of enterprise, because that's one of my areas that I harp on people, is it's not just about the project. There are lots of other things we could talk about in this area. I know you have a book coming out.
That is correct.
And you have a new course on managing technical debt. So these are resources that are available. SATURN will also be featuring more about technical debt. What do you have coming up for SATURN?
Yeah, so at SATURN, actually, we have several sessions. I'll let Felix talk about some of the ones that he'll be leading. So first.
Right. So we have two sessions over there. The one gets down to the basic within the project and saying, as I just said, we need to get data. We need to make the case why certain things has to happen. The best thing we saw was to do reviews. Design reviews. Design reviews that may actually, depending on what your environment is, based on code. But design reviews, and make it iteratively, do it often in small pieces to collect the data. And then in another talk, we'll talk about then how to take that data and then actually now address the enterprise level. Okay. So how can you make the case to whoever gets the funding that actually something has to happen.
There's really an ROI for this.
Excellent.
And we'll be teaching a one-day course on technical debt, and the attendees, we're hoping, will be able to get the ebook. Actually, the book should be out by then.
Very good.
And also we have several other resources. A lot of the stuff that we've written about is publicly available, and I think Shane will make these available to the listeners. But we also have the Technical Debt Conference that is meeting now yearly, that brings both industry as well as tool vendors and researchers together.
And that's also
a resource. And this year it's in Montreal.
In May also,
in May, at the end of May. And so what I like about the technical debt aspect is people are working together because this is a problem in all of the projects. And architects are also coming up with that as helps and practices. So those are all available to the listeners, and the presentations are online. So it makes sense.
Thank you both. And I want to thank John and Ben also for joining us today. I hope this was useful to our audience, and we look forward to seeing some of you at least at SATURN, as well as taking advantage of some of the resources.
Yeah, I just want to thank Suze for the great moderation today. Thank you for your time. Again, thanks everyone for attending. There will be a follow-up email sent out tomorrow morning with the archive once we clean it up a little bit. That'll have a link to the slides, which has all the resources that were mentioned today. We'll put a link to the 2017 What Makes a Good Software Architect as well. So look for that email in your inbox tomorrow morning. Thanks again, everyone. Have a great day.